Welcome. This video is for Physics Module 15, Electric Circuits. I'm going to be doing two different videos. This first one we're going to mainly talk about Ohm's law, and the second one will be looking more at the mathematics of circuits. At the top of this worksheet, you'll see that I've listed a couple of websites that would be really helpful. So you might want to go look at those before you watch this. And also the labs for this chapter, just follow the labs in the textbook. Most of you probably have the supplies at your house. If you don't have bulbs, if you have some old Christmas lights laying around that you can cut apart, that makes a great source of bulbs for the labs. And I am going to be sending you also handouts on how you can do those labs, slightly different than the ones in the book. Okay, also at the top of this worksheet, I've listed all the variables that have to do with the electric circuits. And you can refer to this. It lists all of the units associated with the variables. The most important equation that we need to talk about today is Ohm's law, and it's voltage equals current times resistance. And I'm going to go through each of those a little more thoroughly here. So what current is just the change in charge over time. So as current flows, the more the charge is able to flow through over a period of time, the higher the current. There's also, I have this little diagram here at the bottom of these men trying to go through the tunnel. This is a really good depiction of the Ohm's law. You can see that the character whose name is Amp is trying to get through the tunnel. That is the current that's trying to get through. Voltage is the push that's causing him to go through the tunnel. And ohms is the resistance that's trying to keep him from going through the tunnel. So that's just a good description of kind of what each of those three variables are. So we're just going to use variations of Ohm's law to solve these problems. The first one, while cooking dinner, Elizabeth's oven uses a 220 volt line and draws 8 amp of current when it is heated to its maximum temperature. What is the resistance of the oven when it is fully heated? So this is just using Ohm's law. I'm going to write the variables down here. Voltage is 220. Current, which is amp, is 8 amperes. So this is just a simple algebra problem, rearranging the equation to solve for R. Okay, so 28 ohm. Okay, the second problem. Household current in a circuit cannot generally exceed 15 amps. Okay, an amp is how many coulombs per second. So I'm going to write coulombs per second. That's how much a household circuit can handle. What is the maximum amount of charge that could flow through this circuit in a course of 24-hour day? So if we know it can do 15 coulombs per second, we just multiply that by how many seconds in a day. We know there's 60 seconds per minute, 60 minutes per hour. So that's 3,600 seconds per hour times 24 hours in a day. And there's your answer. That's how much current can flow through your house in a day. Okay, one more. Turn it over on the back. Okay, Arthur's car radio will run from the 12-volt car battery that produces a current of 0.2 amps, even when the car is turned off. The battery will no longer operate when it has lost 1.2 times 10 to the 6 joules of energy. If Arthur gets out of the car and leaves the radio on, how long in hours will it take for the car battery to go completely dead? So write your variables that you know. Voltage 12. Current is amps. And we know joules. Okay, now one thing we haven't talked about is power. So power is just joules per second. So if you look at your front page, power is given in wattage. Power equals watt equals joules per second. So we know his car battery has that much potential energy. How long will it take for all that potential energy to get used up? Well, there's the other equation on the front. We can calculate power is current times voltage. So all of these equations are derived in the textbook, and it goes to how they're all derived. So power, we're going to figure out the power. So the car radio can pull 2.4 joules per second. We know the total amount of joules, so we're just going to figure out that time. We'll solve for T. Okay, do the math on your calculator. Okay, 5 times 10 to the 5th seconds. Convert that to hours. 140 hours. Okay, at the bottom of this worksheet, there's a table there for you to calculate the electrical usage of common household items in your house. I'm not going to go through all those, but just use these equations and fill out that table, and I've put the answers at the bottom of the worksheet for you to check to make sure you're doing these problems correctly. Okay, see you.